Diethylamine is a secondary aliphatic amine, consisting in an ammonia molecule with two ethyl groups instead of hydrogen atoms. It's a volatile, alkaline, and very stinky clear liquid at normal conditions, widely used in pharmaceutical industry. It's used mainly to form salts, as diclofenac, diethylamine, and of course, in the very last step of LSD synthesis, converting lysergic acid into actual LSD. In this video, we will be synthesizing diethylamine from the acid and basic amide hydrolysis of DEET, or diethyltoluamide, a common insect repellent. DEET is easily found in commercial solutions between 15 and 40%. Rebel 100 is almost 100% DEET, so I do recommend that one. I bought these because they were in offer. In the label, there were only 3 components listed: ethyl alcohol, DEET at 15%, and fragrance. First, open the atomizer and make a hole to release the propellant gas.
Para que
Then, pour the content into a flask. It could be a round bottom or conical flask. I prefer conical flask because no bodies needed. Drop the stir bar, settle up the distillation apparatus, and turn up the heat. After a while, ethyl alcohol and the other possible volatile components are distilled. After all the solvent being removed, around 66 milliliters of DEET were obtained. Then, I added 100 milliliters of 36% hydrochloric acid and 200 milliliters of 80% hydrochloric acid to the DEET, as you can see. To control the release of HCl gas, it's convenient to attach the condenser into a sodium hydroxide solution. Be sure to let an entrance to air so a suction does not occur. Then, reflux was set for 3 hours. As I discovered later, it was just not enough. No near enough indeed. In the meantime, let's take a look to the mechanism. Nitrogen acts as a pi donor, displacing an electron pair to the oxygen atom. The negative oxygen atom takes an acidic proton of the medium, and this salt is formed. Next, water acts as a nucleophile, moving an electron pair to the nitrogen atom. A proton transfer occurs between the oxygen and nitrogen atom. The oxygen forms a double oxygen-carbon bond, kicking out the diethylamine. And, as the last step, diethylamine takes the remaining proton. When the reflux was finished, sodium hydroxide was added until a pH of 13 was reached. A short pad distillation apparatus was placed and the heat was turned up. As I suspected, only a few drops came out at 55 C, boiling point of diethylamine, because few amide was hydrolyzed. The distillation continued and the water distilled had a very fishy odor, so I kept it. The distillation was stopped and the layers were separated, keeping the upper organic layer. 350 milliliters of hydrochloric acid at 20% were added and the reaction was put into reflux for 14 hours. No HCl gas was released because it was isotropic HCl. Cold water and ice was continuously added. After the reflux was over, sodium hydroxide was added until a pH of 13 was reached. As you can see, very alkaline vapors of diethylamine was seen in this test paper. A short path distillation apparatus was put again, and around 4 milliliters came out at 55 C. When all of the distillate came out, I kept distillating water because it has a very fishy odor, and I kept both distillates. So far, way less than the half of the amide has been hydrolyzed, so I tried the base hydrolysis. The layers were separated again, and 200 milliliters of glycerin, 35 milliliters of water, and 42 grams of sodium hydroxide were added. Warning: it was too much sodium hydroxide. 20 grams would have been perfect. The round bottom flask was set in a glycerin bath in order to reach very high temperatures, speeding the reaction dramatically. Let's talk about the mechanism. First, hydroxide anion acts as an electrophile, displacing an electron pair to the oxygen atom. This oxygen atom forms a double bond to the carbon and kicks out diethylamine in its deprotonated form. This diethylamine takes a proton of the remaining carboxylic acid and is released in its free base form. When the bath was around 100 C, all the water was distilled out, and the sodium hydroxide started precipitating. The stir bar had a hard time trying to mix the reaction, but anyway, diethylamine started coming out when all the water finished distilling. The bath was around 200 C. I moved the reaction to a conical flask and removed about half of the sodium hydroxide. I placed a bigger stir bar and definitely the reaction worked better. Two phases appeared on the receiving flask, the upper being diethylamine and the lower being glycerin with water. After 3.5 hours, no more distillate was coming out, so I finally shut the reaction. Until this moment, I only have a bunch of distillates from the acid and basic hydrolysis. So I first mixed the acid ones in a round bottom flask and started a short path distillation. I was so happy when around 8 milliliters of diethylamine was collected before the temperature started rising. I did the same with the basic hydrolysis distillates, and I obtained almost 12 milliliters of diethylamine. As you can see, alkaline vapor came out from the flask. At the end, I got 19.5 milliliters of diethylamine, corresponding to a 50% yield, which I'm not proud of. But considering the mistakes and moving the reaction from several flasks, I think it will be worse. Thank you for watching.